Alright, this is Chapter 3, Section 4. This is the second video. So now we'll go through a scenario where you have to do some calculations in each one of the cells of a contingency table or two-way table. This is a pretty common one with the cat and the mouse. You'll see the variations of this from within many books. So essentially there are three doors. The cat has to pick a door and then try to catch a mouse in each door. And they have a 1/5, 1/4, and 1/2 probability of catching the mouse at each particular door. But you have to account for the fact that you can't pick all three doors, right? And we're assuming that they have no likelihood of picking any one door over another. So each of these is a 1/3 chance of being picked, essentially. Right? So the probability of catching, or the mouse was caught, right, depending on your context of present or past tense, right, or future, is 1/5, 1/4, and 1/2, correct? And likewise, it's 1/3. You would have picked it either way, right? Whether you caught it or not, right? But if it's 1/5 to catch it, then you'd 4/5 the time you're just out of luck you didn't catch your mouse, correct? If 1/4 you caught it, then 3/4 you didn't. And if it's 1/2 you did, it's 1/2 you didn't. So it looks like the third door is probably your best bet, right? So that's 1/15 and 4/15, and that's 1/12 and 3/12. Right, and then that's 1/6 and 1/6. So at this point you could add and get your marginal numbers, but that's a bad idea. The books tend to do that, but I would make your life easier and do common denominators. So 12, 15, and 6, the common denominator is 60. So if I make common denominators, that's what, 4 to 60, right? Times 4 times 4 is 16 out of 60, right? Times 5 would be 5 out of 60, right? Times 5 would be 15 out of 60, right? Times 10 would be 10 out of 60 for both of these, right? Oops, 60, 10 out of 60. Okay. And then at that point, add, I'm saying, your rows and your columns, and then your grand total. Add it all up. Okay, so if I add them, I get, 19 this way, and I get 41 this way, right? 19 this way, 41 this way, 20 this way, 20 this way, and 20 this way, right? And then obviously it'll be 60 out of 60. Right? Okay, so let me just type those real quick. So copy and paste. Okay, let's answer some questions now. What's the probability the cat does not catch the mouse? So the probability of caught, right? Not, right? That's asking a singular thing. That's a marginal probability. Not caught is this one right here, right? So that's 41 out of 60. Notice I didn't have to do this one over here this time, right? Because it's not a quantity, it's a probability in there. Because you look at the prior problems, you'll notice that the items in there were quantities, not probabilities, right? I could divide by that, but that's a 1. Dividing by 1 doesn't change it, right? So this one's a little bit different because all of these were quantities in the past. So I had to divide by the 100, right? Don't have to do that here. It doesn't make any difference. Okay. So that was a marginal probability. It was just asking for one thing, right? Okay. So let's say we want to do door 1 and not catch, right? So door 1 and not, it was not caught, right? Depending on your tense that you're using when you ask the question. Okay, so that is a joint probability, right? Because it's both two things and. So door 1 and not caught would be this one right here. So 16 out of 60. And again, you can divide it by this if you want. Won't make any difference because it's already accounted for, right? So that's a joint run because it involves two, correct? An and. Okay, this one's an interesting one. Let me make it a little bit smaller here. There we go. Okay, so we want door 1 or door 2, right? Given they were caught. Okay, so that's the probability of door. I didn't do that very well. Let me turn that on again. I double-clicked. Door 1, right? Oh, I'm sorry, or door 2. I read that wrong. Or door 2, right? Parentheses. Given it was caught, right? Given you were caught. So that's a little bit different. So it's got an or inside of a conditional, which is fine. You still do the and on top. So it's the probability of door 1 or door 2. Door 1 or door 2, right? And caught. All right, so that's on top over the probability of caught, right? Because that's the condition. That's the condition. Okay. So a single probability is a marginal, right? So being caught is right here. That's a marginal, right? So that's your 19 out of 60. Okay. The top one will be a little bit interesting. It is a joint one, right? Because it's caught and with the door, right? So caught with door 1 and caught with door 2. So I actually have to add these two together, right? Because it's an or, which means you add them together, right? So it's a joint, but you have to add them together since it's two of them. So it's 4 plus 5, right? Out of 60. So that's obviously 9 out of 19 when we simplify, right? So that's a conditional probability, essentially, because under the condition that was caught, essentially, right? Okay, so we went through some examples that were counts. We went through some examples that were probabilities, where we had to figure them out ahead of time. And it also can be decimals. So if you add up all these ones here for the different crimes that can be committed, it doesn't work out to nice numbers, which is fine, right? It doesn't have to be whole numbers, right? So let's say I do robbery, right? So robbery is a singular thing there, so that's a marginal probability, right? So that's going to be robbery is right here, so this is this one out of this one, correct? That's a marginal probability. And then here's the thing, when you divide it, it doesn't work out perfectly, right? It's going to be approximate. So either keep it in this form or do approximately, basically. And you can swing the decimal over if you want to. So you could do this. You could do copy, paste, and just get rid of move it one decimal place over. That's still fine, still equals, and it'll still equal this. The problem is it goes on forever because it's irrational, right? So my suggestion is to give both, because obviously there's some rounding involved, and you have to, how much do you want to round, and why do you want to round, and all that kind of stuff, basically. All right, so here's the and probability, right? So 2010 and burglary, so it's a joint probability, correct? So 2010 and burglary will be 701 over this. And again, you run into the same problem, that it is not a exact probability, so you have to do some rounding, you know what I'm saying? But give the fraction, right? Or move it over a decimal, right? So if you move it over a decimal, if you do that, it's going to be 7010 over the 45207, right? Oop, 7. Okay. All right. So 10 or burglary, right? Okay. So these are two individual marginals, right? So 2010 is right here, right? And then the burglary is right here, correct? So I went this way to get that number, and I went this way to get this number, correct? So this is out of the 45, 20.7, 20.7, right? That's not very good. 20.7, right? So I have to add those two numbers, right? So the 2853 plus the 2871, right? But remember, whenever you do an or scenario, right, you have to subtract out the overlap. Well, what's the overlap? Well, we hit this one twice, didn't we? So that's 701. Okay. All right. So basically, since there is an overlap, those are not mutually exclusive events, right? So add an overlap. Okay, you're going to get approximately that, essentially. So not mutually exclusive event. what we're saying. You could be both, right? It could be the year and that particular thing, because obviously those particular crimes happen in each of those years, right? They could be both, so that is not mutually exclusive. Okay, so let's do a conditional now. So if you remember the trick to this, you can do it in a couple parts, right? So if we do 2011 given assault, it's both, right? So it's the probability of 211 and assault, right? Over the probability of assault, right? Assault. Okay, so both, that's a joint. So 2011 and assault is 26.8, right? So 26.8 over the 45, 20.7, right? Grand total. And we have just assault, which is a marginal probability. So there's that right there, which is the 113.3 over the 45, 20.7, right? So remember the trick, you can just ignore that because it goes away, right? And just do it over there, right? So joint over marginal, right? So that's joint probability, right? Over a marginal probability. Marginal probability, correct? Okay, so you get the 26.8 over 113.3, correct? So that's a conditional probability, right? All right. And then we have the other way around, which is the vehicles and 2008, correct? So we can cheat on this one, I think, a little bit. Let's make this a little bit smaller, right? So if we do this, it's both together, which is a joint, correct? So vehicle and 2008. So 2008 and vehicle, that's this one right here, correct? So it's that number, right? Over the 2008, which is the condition, which is this number right here, right? So it's essentially going to be this one over this one if I cheat, correct? Right? Which is, again, is a conditional probability, right? And again, you can write these in more detail, right? So I could do here, equals, and go in between here. Let's shrink this down. So this is the probability of 2010, right? 2010 plus the probability of burglary. Right? Minus, and we'll do this, and we'll put 2010 and in between, right? Okay. All right, because it could be both, correct? Let's get that mutually exclusive out of there. That's kind of in the way, right? Because that could be true. And again, with these ones here, we can write them out, right? So we can do equals and go over to here. So this is the probability of 2011 and assault, right? Over the fraction of the probability of assault, right? And let's copy that. And let's copy this. Yeah, right? Okay. And again, I cheated with I didn't do the full fractions of those. So over here, right, equals, put that in there, right? And this will be vehicle. It's probably vehicle theft is my guess. And 2008. And 2008. Okay. And again, I cheated. I didn't do the full fractions for both to kind of get right to the answer. Okay.